In the sultry air of Southeast Asia, where humidity seemed palpable and the sky was perpetually hazy, a sound resonated that was unmistakable. It was a heavy, rhythmic rumble, shaking the very earth. Two enormous rotors, spinning in opposite directions, carved a path through the dense atmosphere, creating an aura of incredible power around the machine. This helicopter, resembling a giant railway carriage in its shape, became a symbol of one superpower's technological superiority and a coveted dream for engineers of another. On that memorable day, when one such machine touched its wheels to the damp soil, not on an American base, but in territory controlled by resistance forces, the course of aviation history altered its direction. The pilot, emerging from the cockpit, understood that he was leaving behind not merely a heap of metal, but a key to secrets that had been guarded for decades across the ocean. This was no ordinary trophy. It was a challenge thrown to Soviet designers, and the beginning of one of the most ambitious operations of technological borrowing in the history of the Cold War confrontation. The jungles of Vietnam in the mid-1960s transformed into something more than just a battlefield between ideologies. It was a colossal testing ground, where the boldest engineering ideas were put to the test in real conflict conditions. The United States of America gambled on air mobility, turning the helicopter into the primary tool of warfare. While in the European plains preparations were underway for tank breakthroughs, here, in conditions of impassable terrain and mountains, the ability to quickly transfer artillery, cargo, and hundreds of soldiers to any point on the map became crucial. The main jewel of this approach was the CH-47 Chinook. Its unique tandem rotor configuration allowed it to ignore many limitations faced by classic machines. The Soviet Union, closely observing every move of its opponent, realized that it was stuck in an era of heavy but less maneuverable machines. The gap in materials technology, automatic stabilization systems, and engine efficiency was becoming critical. Moscow demanded not just to create an analog, but to understand exactly how the Americans managed to achieve such characteristics, and the war provided an ideal opportunity for this. The main conflict unfolded in plain sight of the entire world, but its true essence was hidden in the details of designs and the chemical composition of alloys. From the outside, it looked like a series of clashes, where American technology demonstrated marvels of survivability and lift capacity. Soviet military advisors, in the thick of events, received reports on how Chinooks extracted downed aircraft or delivered entire batteries of howitzers to the tops of inaccessible hills. For the Soviet command, this was a painful reminder that their own Mi-6s, though world record holders in weight, required gigantic landing pads and suffered from vibrations. The contradiction was that, possessing enormous resources, the socialist industry could not replicate the lightness and strength of Western models. Every crash of an American helicopter became an object of pursuit. Special intelligence groups worked ahead of time, striving to reach the wreckage before American aviation could destroy it to hide the secrets. It was a race against time, where the stakes were the technological sovereignty of future decades. The inner world of the people involved in this process was filled with no less tension. Soviet engineers, such as Mikhail Mills' successors, were under immense pressure. On the one hand, they were proud creators of an original school of helicopter design. On the other, they faced technical solutions that seemed beyond their grasp. When the first components of captured machines arrived in the secret workshops of the Moscow region, designers experienced a complex feeling, a mix of professional admiration and a burning desire to prove they could do better. Personal ambitions clashed with the necessity of strict copying. Every screw, Every rivet was studied under microscopes. People worked 18 hours a day, trying to decipher the formula of the composite materials used in the rotor blades, which allowed American helicopters to fly in extreme heat and humidity without losing lift. It was a conflict of pride and pragmatism, where the fear of falling behind progress was stronger than ideological dogmas. On an ideological level, this clash exposed a fundamental paradox. The United States built its technology based on principles of maximum efficiency and pilot comfort, leveraging the power of private corporations and competition. The centralized and planned Soviet system tried to absorb these achievements to prove the superiority of its own system. A philosophical question arose. Can borrowed technology become the foundation for genuine progress, or does it condemn the follower to perpetual catch-up development? The capture of the Chinook and other equipment was an acknowledgement that war is not only a struggle for territory, but also the fastest, albeit violent, way to exchange knowledge. It was an attempt to steal the future and make it their present, turning the battlefield into a giant drafting table where new aviation standards were written in blood and sweat. The situation changed dramatically when Soviet specialists got their hands not just on a piece of skin or a broken engine, but an almost complete aircraft, captured after the fall of the South Vietnamese regime. It was as if archaeologists had found a living dinosaur. The operation to evacuate this giant became a masterpiece of logistics. The enormous An-22 anti-transport aircraft, itself a marvel of engineering, made a secret flight to retrieve the valuable cargo. As the helicopter, with its rotors removed, was slowly rolled into the belly of the Soviet plane, the officers present understood. This was the beginning of the end of the American monopoly on certain technical solutions. At this moment, a shift in perception occurred. Soviet aviation ceased to look at the West only through rifle sights or spy satellite lenses. It began to touch this progress with its hands, disassembling it atom by atom in the laboratories of the Central Aero Hydrodynamic Institute. The culmination of this process came in closed hangars where American technologies underwent total analysis. The biggest revelation was the main rotor blades. The Americans used a honeycomb structure with fiberglass and special adhesives, which made them incredibly light yet rigid. Soviet counterparts of that era were heavy, metallic, and had a limited lifespan. Studying the Chinook's navigation and automatic flight control systems showed that electronics could take on the lion's share of the pilot's work, ensuring stability in the most complex modes. All this data flowed into a single center, where the image of a new machine, destined to eclipse all existing ones, was formed. This is how the Me-26 project was born. It was not blind copying. It was a synthesis of Soviet gigantomania and American sophistication. Every solution observed from the enemy passed through the filter of the domestic school, adapting to harsh operating conditions from the Arctic to the deserts. This experience taught humanity and engineers an important lesson that remains relevant to this day. Technology knows no boundaries, no matter how politicians try to erect them. War, with all its tragedy, is a powerful catalyst for knowledge, forcing the best minds on the planet to work at their limits. We see that true progress is born at the intersection of competition and a deep study of the opponent's experience. Today's super heavy helicopters, which extinguish forest fires, build power lines in the mountains, and save thousands of people in disaster zones, carry within them particles of those very secrets obtained in the jungles 50 years ago. It is important to understand that borrowing is only the first step. True mastery lies in the ability to develop an idea, transforming a trophy into a tool of creation. The legacy of that confrontation lives on in every detail of modern machines, reminding us of the high price paid for the ability to conquer the sky with such ease. Returning to that scene on the wet earth of Vietnam, we no longer see just an abandoned helicopter, but a starting point for a great leap. That machine, once a formidable weapon in the hands of the enemy, ended its days in a research hangar. But its spirit, its technical solutions, dissolved into thousands of other aircraft flying today under different flags. This is a cycle of ideas, where one event inevitably leads to another. The Soviet Union was able to turn the battlefield into its laboratory, and this experience forever changed the face of world aviation. In the silence of modern design bureaus, where computers now work, that distant echo roar of two rotors can still be heard, which once blazed a trail to new horizons, proving that in the world of high technologies, nothing is definitively lost. There is only what is yet to be studied and surpassed. It is worth considering in detail how exactly the process of delivering these colossal machines to the Soviet Union took place, because it was a separate operation worthy of a thrilling novel. Under the strictest secrecy, under the cover of night and disinformation campaigns, parts of American equipment were moved across the borders of several states. Sea routes were used, where in the holds of ordinary dry cargo ships, hidden behind boxes of agricultural equipment, engines and elements of navigation systems rested. Each such voyage was fraught with enormous risk. If Western intelligence agencies had learned about the nature of the cargo, the consequences could have been unpredictable. However, the thirst for knowledge was stronger than the fear of an international scandal. Specialists in Moscow awaited these shipments with an impatience comparable to awaiting a miracle. Special attention was paid not only to helicopters, but also to communication equipment, as well as identification friend or foe systems. American radio electronics of that period significantly surpassed Soviet ones in terms of miniaturization and reliability. The opening of the Chinook's control units allowed Soviet microelectronics engineers to see a completely different approach to circuit board layout and the use of semiconductors. This gave a powerful impetus to the development of the domestic instrument-making base. Entire institutes were created whose task was to decipher the algorithms of American radars. Thus, Vietnam became for the USSR not only a testing ground for ideological resilience, but also a university of applied sciences, where the best examples of enemy equipment served as textbooks. One cannot forget how this process affected the fates of specific individuals. Test pilots, who were the first to sit at the controls of captured aircraft at secret testing grounds, described their sensations as something fantastic. The smoothness of the ride, the machine's obedience to every hand movement, the magnificent visibility from the cockpit, all this sharply contrasted with what they were accustomed to. These reports landed on the desks of high-ranking officials, forcing them to revise budgets and priorities for scientific development. The influence of captured technology was felt even in such minor details as the ergonomics of seats and the arrangement of instruments on the panel. Soviet aviation became more humane, pilot comfort-oriented, which ultimately increased the overall efficiency of task execution. It is also interesting that some technical solutions discovered during the study of the Chinook proved so difficult to reproduce that Soviet scientists had to invent fundamentally new methods of metal processing. For example, the unique alloys used in the transmission required the creation of special furnaces and vacuum melting conditions that previously did not exist in civilian industry. Thus, the military trophy became a locomotive for a whole range of related industries, from metallurgy to polygon chemistry. This was a cumulative effect where one captured piece of equipment triggered a chain reaction of innovations throughout the vast country. The paradox was that the United States, striving to suppress resistance in Vietnam with its most advanced developments, inadvertently armed its main opponent with knowledge it could not have obtained otherwise. Every lost machine was like an open book that the Soviet Union read with exceptional thoroughness. This was a peculiar form of tax on technological leadership that America paid in the jungles of Southeast Asia. Soviet engineers learned not just to copy, but to predict the paths of Western thought, which subsequently allowed them to reduce the time for developing their own promising projects. Looking today at photographs from those years, where American helicopters with northern markings or even without them stand against a background of palms, we understand that we are seeing not just a military chronicle. We are seeing a process of global intelligence exchange that took place under the harshest conditions. These machines, having become involuntary travelers between two worlds, played the role of a bridge through which ideas flowed from one culture to another. And even if the goals of that time were far from peaceful, the result of this process in the long run served all humanity, making aviation safer, more powerful, and more perfect. An important chapter in this story was the work with blade materials. For a long time, the concept of a steel spar dominated in the Soviet Union, which, although reliable, limited the size of the rotor and created enormous loads on the hub. The American approach using fiberglass and honeycomb filler initially seemed too fragile for harsh conditions. However, strength and endurance tests showed that this direction held the future. Soviet chemists had to synthesize new types of resins and hardeners in the shortest possible time that could compete with foreign analogs. This work was carried out under the strictest secrecy, and many of those who participated in it remained unsung heroes of the technological front. Their work made it possible to create 32-meter diameter rotors for the Mi-26, which is still an unattainable record for production aircraft. The Chinook's navigation system also presented many surprises. For Soviet engineers, it was a revelation how integrated the instruments were in the American machine. Sensors that automatically adjusted the blade position depending on air density and wind speed allowed the helicopter to literally hover in place with an accuracy of several centimeters. For the operation of a heavy crane, which both the Chinook and the future Soviet Giant essentially were, this was critically important. The introduction of such systems into Soviet practice required a rethinking of the entire concept of on-board computing systems. The transition from analog solutions to digital algorithms began precisely then, under the influence of studying captured control units. Another aspect that impressed Soviet specialists was the system for maintaining equipment in the field. The Chinook was designed so that most components could be replaced or repaired with a minimal set of tools right on the front lines. The modularity of the design, which now seems self-evident, was a breakthrough in those years. The Soviet school always gravitated towards monolithicity and complexity in maintenance, requiring the participation of factory specialists. Studying the American approach forced a change in design philosophy, making new machines more maintainable. This significantly increased the combat readiness of helicopter regiments and simplified the operation of equipment in remote regions of the country. When we talk about a technological leap, we often imagine the sudden epiphany of a brilliant scientist. But the history of helicopters shows that more often it is the result of painstaking, almost detective work to collect and analyze scraps of foreign experience. The Vietnam War provided the USSR with a unique chance to look 10 to 15 years into the future, and this chance was utilized 100%. Every technical solution, Every successful curve of the fuselage or engine layout scheme went through the crucible of testing and critical reflection. As a result, Soviet helicopters acquired that very stature and power that make the whole world look at them with respect even today. The transformation that occurred in the minds of designers led to the creation of a machine that surpassed the original in many parameters. The Mi-26 became not just a response to the Chinook, it became a new word in aviation, capable of lifting 20-ton loads over vast distances. But in its DNA, the lessons learned from the wreckage and intact aircraft brought from across the ocean forever remained encrypted. This is a story of how rivalry turns into apprenticeship, and war into a harsh but effective school of progress. And although those times are long past, the principles laid down then continue to work, reminding us that in science and technology there are no enemies, only tasks that need to be solved using all available means. Concluding this narrative, we return again to the image of that very first Chinook, standing under a tarp in a secret hangar. Its rotors no longer spin, its engines are silent, but its story continues in every flight of a modern heavy helicopter. It fulfilled its mission, becoming an unwitting teacher for those who were supposed to be its adversary. This is the great irony of history. Tools of destruction often become seeds for future creation. Soviet helicopter engineering made its grand leap, pushing off from the deck of American machines, and this flight continues to this day, carrying us further and further to new heights of engineering thought, where the boundaries between ours and theirs are erased in the face of the pure genius of the human mind. The history of studying American technology in the USSR was not limited to helicopters alone. Vietnam became the place where jet fighters and anti-aircraft missile systems first massively clashed in the sky. Captured airborne radars from F-4 Phantom aircraft and Sidewinder missiles were analyzed with the same meticulousness as Chinook components. But it was helicopter technology that yielded the most visible and rapid results in the civilian sector of the economy. The vast expanses of Siberia and the Far East needed powerful machines to develop oil and gas fields. Technologies developed from military trophies were put to the service of peaceful construction, allowing entire cities to be built where even tracked vehicles could not pass before. This clearly demonstrates that any advanced technology has a dual purpose, and those who can adapt military achievements to civilian needs faster than others gain a strategic advantage. The Soviet Union, using the war in Vietnam as a proving ground, was able not only to strengthen its defense capabilities, but also to lay the foundation for a powerful industrial leap. It was a game of extremely high stakes, where the price of an error could be measured in decades of lagging behind. But thanks to the dedication of engineers and the skill of intelligence officers, this historical exam was passed successfully. Today, when we see the enormous Mi-26 hovering over a construction site or delivering humanitarian aid to affected areas, we must remember that its power is not only the result of the work of domestic design bureaus, but also the legacy of that complex, dramatic time. It is a living monument to an era when the world was split into two camps. But intellect and the thirst for discovery found ways to overcome any obstacles. The history of helicopters is a story of how important it is to look forward, learn from everyone who achieves success, and never rest on one's laurels. Only in this way can one stay at the forefront of progress in a world that never ceases to amaze with its technological twists. Gradually, layer by layer, we have revealed a picture of a grand intellectual battle. This was not merely the theft of ideas, it was a profound rethinking of the very foundations of flight. Soviet designers were able to take the best of Western thought and combine it with traditional Russian reliability and scale. As a result, the world received machines that still have no equal. And it all began on one stuffy Vietnamese day when a heavy helicopter changed hands, becoming not just spoils, but a priceless gift to science. In conclusion, it is worth emphasizing that the lessons of Vietnam for aircraft manufacturing remain the foundation for many modern developments. The principles of aerodynamics, material chemistry, and the logic of building control systems, which were just emerging in laboratories through the study of trophies, have now become standards. We continue to fly on the wings of those discoveries, and every new helicopter taking to the sky carries a piece of that history when the war in the jungle became a school for designers, and captured equipment the key to future greatness in the skies. This is a continuous process in which the past nourishes the present, and the present builds the road to tomorrow, where technology will serve solely for the good of humanity, preserving the memory of the price at which it was obtained. Every detail of the Chinook, every curve of the Mi-26's blades, these are letters in the great book of human history. We learn to understand the language of metal and electronics, even if it was written on the other side of the world. And this skill of understanding, adapting, and improving is the guarantee that our upward movement will never cease. Looking at the sky, we see not just machines. We see the embodied will for progress, which is stronger than any conflicts and higher than any ideologies. This is the main resonance of those events, the echo of which sounds in every turn of the propeller, in every successful mission, and in every new record set by man and his winged machine. It is also impossible not to mention how Soviet specialists solved the problem of reverse engineering in the absence of original technical documentation. This was a process comparable to deciphering ancient hieroglyphs. Engineers literally had to guess why a particular shape was chosen for a certain bracket, what temperature regime was required for hardening a specific gear. Thousands of experiments were conducted to recreate the production conditions that existed at Boeing Vertol factories. This intellectual assault allowed Soviet science to make a qualitative leap in the methodology of researching foreign technologies. Standards of analysis were developed, which were subsequently applied to the study of a wide variety of foreign equipment samples, from microprocessors to spacecraft. Thus, the work on the Chinook became a school of systemic analysis for an entire generation of Soviet scientists and technicians. The influence of this experience can also be traced in modern Russian helicopters. The logic of cockpit layout, the use of new generation composite materials, vibration suppression systems, all this has its roots in those detailed reports of the 70s. Even modern digital flight control systems are largely based on an understanding of the principles of automation that were laid down in American machines of that time. We see a continuity of ideas that has overcome the collapse of states and the change of economic formations. This proves that genuine engineering achievements have a life of their own, independent of political context. They become part of the common human technological baggage, which we continue to supplement and develop, striving for the ideal of safety and efficiency in the air. Ultimately, the story of how the Chinook helped Soviet helicopter engineering is a narrative of the triumph of curiosity and perseverance. It is a reminder that even in the darkest times, the human mind seeks opportunities for growth and knowledge. The Vietnamese jungles concealed many tragedies, but they also became the cradle for technologies that today save lives and help develop civilization. And when we hear the characteristic sound of working turbines in the sky, we can for a moment remember those who, in the silence of laboratories, disassembled foreign secrets screw by screw to one day create something of their own, even more perfect and powerful. This flight of thought continues, and its horizons are still boundless.